When performing computational fluid dynamics, or CFD analysis in SOLIDWORKS Flow Simulation, one of the first decisions you need to make when setting up a study is choosing between internal and external analysis. The correct choice depends on how the fluid interacts with the model and the scenario you're trying to analyze. At a fundamental level, we should be asking ourselves whether the fluid flows around or through the model to help make that determination. Let's break it down in today's 2-minute tech tip. We use an internal analysis when we're concerned with the behavior of the fluid entirely contained within our model. For example, we can think of a pipe carrying water or air through a duct system or manifold. The fluid moves through an enclosed space, bounded by the model with defined inlets and outlets, and we may want to predict parameters like pressure drop, velocity, or temperature changes within the system. With internal analysis, we're not concerned with how the fluid inside the system interacts with the outside environment. In fact, to prepare a model for internal analysis, we need to seal off any openings with additional geometry called lids in order to define a watertight internal region, separating it from the outside environment. In contrast, we use external flow analysis when we're interested in the effects of how fluid moves around the outside of our model, or anytime we want to capture the effects of a large open environment. Imagine we want to predict the performance of an aircraft wing. We're interested in the interaction of the wing and the outside environment, the large volume of air flowing past it, with the goal of predicting lift and drag forces. This is a great use case for an external analysis, which you can think of for any problems where you need a virtual wind tunnel. It's also worth noting that when it comes to external analysis, there's generally no special geometry preparation required. But what if we need to analyze both internal and external flow in a single system? What method should we choose? An example of this type of analysis might be an electronics enclosure, where we want to capture how heat is transferred within the enclosure, as well as carried out of the system to the external environment. To fully understand the system's behavior, including effects like natural convection, we would need to simulate both the internal and external style behaviors. In SOLIDWORKS Flow Simulation, we can set this up as a special case of external analysis. Since the external analysis does not require us to seal off any regions, it supersedes the internal analysis in this case. We can use external analysis to seamlessly represent the fluid inside and outside the enclosure. So to summarize, we use internal flow analysis when we're concerned with the behavior of fluid fully confined within our model, such as flow in pipes or ducts. We use external flow analysis when we want to characterize fluid behavior as it moves around our model, like airflow over an aircraft wing, or when we need to examine the behavior of a fluid that flows both within and around our model, such as convective heat transfer analysis of an electronics enclosure. By accurately bounding the problem we're trying to solve and choosing the correct type of analysis, either internal or external, we can ensure that we achieve accurate and reliable results quickly in SOLIDWORKS Flow Simulation. To learn more about SOLIDWORKS Flow Simulation or computational fluid dynamics in general, including how to set up internal and external analyses from scratch, check out the Solid Professor course Introduction to CFD, which covers introductory background theory as well as practical case studies. Thanks for watching.